Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's the only way you can keep me going, energized and inspired. Now, if my videos are helpful to your studies, please don't forget to subscribe. With the first method, determine the support reactions. EI is 100,000 kilonewton meter square. Support settlements 5 mm at A, 18 mm at B, and C 12 mm. So let's solve this by the first method. And this problem is also solved in example 159 by the three moment equations to verify our answers here. So imagine that this is the beam, horizontal beam, and there's no settlements at A and at C anymore, only at B. Let's compute for the net settlement at B. This is highly exaggerated, of course, because 5 mm and 12 mm compared to the spans, which is 6 plus 8, that's 14,000 mm, then this remains horizontal actually. So that's 12 mm. And let's solve for this HB here, which is from this horizontal distance to this imaginary yellow line. So by this is 7, therefore 12 minus 5 is 7. So therefore, by similar triangles, HB as to 6 equals 7 as to 14. So HB equals 3 mm. If HB is 3 mm, since the settlement at support B is 18, the net settlement at B therefore is downward, of course, settlement is 18 minus 5 mm minus 3 mm, and that is 10 mm. So let's solve this by uh, double integration method. So imagine that the support at B is removed, so we can compute reaction at A, call that X, and we extend the loading because we apply double integration method. So summation moments equals 0, RA times 14 equals 20 times 6 times 11 plus 30 times 3. So R sub A is equal to 705 over 7 kilonewton. So let's now have the differential equation. Remember that B is removed. That's why it becomes uh, determinate beam. So EIY double prime equals 705 over 7 times x plus 10 times x minus 6 times x minus 6 over 2. So, sorry, 20 times x minus 6 times x minus 6 over 2. That's why you have plus 10 x minus 6 square. Minus 20 times x over 2. That's why we have minus 10x squared. And minus 30 times x minus 11. EIY prime is 705 over 14x squared plus 10 thirds quantity x minus 6 cubed minus 10 thirds x cubed minus 15x minus 11 square plus c sub 1. There is c sub 1, there is slope at A, but there is no settlement because this is now a reference. And imagine that this yellow dashed line is horizontal. So there's also no settlement at C because this is now the final position of C, and this is our reference axis. Then EIY equals 235 over 14x cubed plus 5 over 6x minus 6 to the fourth plus 5 over 6x to the fourth minus 5x minus 11 cubed plus c sub 1x. Then we can evaluate x by setting when x is 14, y is 0. Remember, this now supports C. So 0 equals 235 over 14 times 14 cubed plus 5 over 6, 8 to the fourth minus 5 over 6, 14 to the fourth minus 5 times 3 cubed plus c sub 1 times 14. Solving for c sub 1 equals negative 1237.5. Knowing c sub 1, we can now solve delta B beyond this yellow dashed line. So EI delta B equals 235 over 14 times 6 cubed minus 5 over 6 times 6 to the fourth minus 1237.5 times 6, C sub 1 times 6. So delta B, EI delta B equals negative 4879.29. Since EI is 100,000 kilonewton meter square and this is 4879.29 kilonewton meter cube, the shortcut to converting delta B to mm is we just divide this by 100 instead. So that means delta B in mm is negative 48.793 mm from this point. So negative 48.793. Since there is already net settlement of 10 mm, so that means there is already 48.793 mm, so that the support will go back to this position. It should be pushed by RB such that the net upward displacement would be 10 mm less than the absolute value of this. So that means delta B due to reaction is only 38.793, and that should be upward. So again, 38.793 is 48.793 minus net settlement of 10 mm. So that's why you have 38.793 mm there, which will be the supposedly displacement when we push this by the reaction at B. So this is the unit upward load at B, B1. So the reaction here is downward, and it is 1 times 8 over 14. 8 over 14 is 4 over 7. Therefore, if we section the beam here by double integration, EIY double prime is negative 4 over 7x plus 1 times x minus 6. Integrating, EIY prime equals negative 2 over 7x squared plus 1 half x minus 6 square plus c sub 1, c sub 3 rather. Integrating again, EIY equals 2 over 21, negative 2 over 21x cubed plus 1 over 6x minus 6 cube plus c sub 3x. There's no c sub 4 because A is a support. Then we can evaluate c sub 3 by setting x equals 14. So 0 equals negative 2 over 21 14 cube plus 1 over 6 8 cube plus c sub 3 times 14. Solving for c sub 3, c sub 3 is equal to 88 over 7. Then from there we can compute FBB in this equation by setting x equals 6. The corresponding displacement here is FBB. If we multiply that by RB, then we should equate that to 38.793 mm. So EI FBB equals negative 2 over 21 times 6 cube plus C sub 3, which is 88 over 7 times 6. So FBB equals 384 over 7 EI, where EI is 100,000. The compatibility equation is FBB RB plus delta B net, which is negative, equals 0. Or simply FBB times RB equals 38.793, but we must convert that to meter. So FBB RB equals 0.038793 meter. 38.793 mm is 0.038793 mm to be consistent. So substitute EI equals 100,000, so 384 over 7 times 100,000 times RB equals 0.038793. So we can now solve RB, which is 70.716 kilonewtons, and that's the answer also in example 159 by the three-moment equation, which is also a force method, but the more direct and shorter way. Then, having found RB, we sum up moment about C to solve for RA using the whole system. So RA times 14 plus RB 70.716 times 8 equals 20 times 6 times 11 plus 30 times 3. So R sub A equals 60.305 kilonewtons, which verifies our answer in example 159. Then summation moment about A, 0, R sub C times 14 plus RB 70.716 times 6 equals 20 times 6 times 3 plus 30 times 11. So R sub C is 18.979 kilonewtons. So note that my equation, static equation, are all summation of moments. So you can check, verify the answer by summing up forces Y. And I will leave that to you.